Hello guys and welcome to African Tech Gurus. Here we cover content relating to technology and today we will be doing the Hello World task. Today is dated the 16th and I hope you have watched the content review. Please make sure you watch it first before you actually do the content so that you're able to understand. Today's main topic was around GCC and the 4 steps that are there that are needed. And let's first do the quiz before we actually do the tasks. And if you liked the previous video, please give it a thumbs up, share it with someone. We are here to help you learn about technology and we take you step by step and we explain each and everything to the best of our knowledge. If there's anything else you'd like us to cover, please put it in the description box and we will definitely be glad to do it. We love you all and let's jump into it. So let me scroll to where the quiz is. So, the first question is what is the common extension for C header files? I hope you know what this is. The main extension for C header files is .h. .h, so the .h represents the header file. The next thing is in which category does C programming language belong to? In which category does C language belong to? So this one, it is a compiled language, and just as a hint, it is a GCC and one of the G's stands for compiler. So this is a compiler language. The next one is what are the different steps to form an executable file from source code? So here when they say source code, it means the actual code that we write in C language. And when they mean an executable file, this is the end result of the GCC compilation stage and everything. So it starts with pre-processing, compilation, assembling, and linking. It starts with pre-processing, compilation, assembly, and linking. So we can actually look for GCC processes and we see what we get. Processes. If we get a video that an image, that will be really nice because it will show us all the steps so that we're able to actually see what is happening. So yes, so here we have this image, this one over here. Let's see if we can open it. So the first one is the pre-processing, which is what happens after the source code has been provided. I hope you remember that it is what is provided after the source code. I hope you can get the image. Yes, here it is. So here we have our source code, which is the very first thing that we type out in our C files, and it is pre-processed. And then here what happens is all the comments are removed and the header, the library that are there, all the content is brought in. And then after that, we have the compilation stage. That's the second step. So here GCC actually does the compilation and it gives us an output which is assembly code. And then now the assembly code moves to the next step, which is step 3, where now the assembler assembles it together. And the fourth step is the linking step. And here we have static libraries that are brought in and to be able to be linked together and form an executable file at the end of the day. So at each and every step, preprocessing gives us an output, which is the input of compilation. Compilation gives us an output, which is the input for assembly. Assembly gives us an output, which is input for linking. I hope you got that. So they are interlinked. And today's task, they really want us to make sure we have understood this, and we will see that as we continue. So, the other question that they are asking is what is the common extension for a C file? For a C file, the common one, the keyword is common, so the common one is .c, which will be at the end of the name of the file, and this will just tell our IDEs and also help us know that this source code that is in this file is C programming language. And then now question 4, the next thing they're asking is which command can be used to compile a source file? Which command can be used to compile a source file? This one is GCC pattern. It's pretty straightforward. And the other question, question 5, which is the last one as well, they are asking us which of the following are both valid common syntaxes in ANSI C and BT and also BT compliant. So this one is not, because with Betty, each and every line needs to have the asterisk. So this one is out. This one is okay because this is a single line comment. So a single line comment, it starts with a forward slash and an asterisk and ends with an asterisk and a forward slash. So that one is okay. The next one that is okay is this third one, because now this is a multi-line comment, and what this means is the very first line, it starts with the forward slash and the asterisk, and any other line that comes after that will just have a single asterisk, but the very last line we will have an asterisk and a forward slash, and the rest are not correct because they don't apply in Betty, they're not Betty compliant, and they are not valid syntaxes for ANSI C. So let's submit our answers and see. We do have one error. Sorry, this one we were not supposed to check them. This is the error. Sorry. Now we can actually submit our answers and get them right. Yes, good. Now we should move to the next step. Yes. So before we move to the tasks, let us look at some of the things that we really want us to do. So here, this is the first preprocessor, and this we always need to check this, otherwise our code will not run. So we need to create a repository called ALX low level programming. The next thing we need to do is create a directory called hello world. This is the name of the directory, and then our files, which will contain the answers to these tasks, are supposed to be named like this. So as I have always advised, make sure you copy paste this as they are to avoid any errors. Yes. And if we move to the top to the requirements, please always make sure you read the requirements, because now you'll be able to understand what is happening. Because, for example, they have said they need to have a repository at the root which will contain the description for the repository. The next thing they need us to do is have a README file at the root of the folder for this project containing a description of our project. So this first README, this one, the first README, it will be contained in our GitHub repository, and the next README is supposed and the next readme file is supposed to be contained in the directory, which is hello world. So I hope you got that one right. If you don't do this, it will not accept. The next thing that needs to happen is we need to make sure we follow Betty style. If you've not been able to understand Betty style, please comment down below and we will take it upon ourselves to actually do a video on that. And the other thing that they want us to do for the shell scripts is we are allowed to only use these few editors, VI, Vim, and Emacs. And the other thing that we need is all script should be exactly 2 lines. So if it is more than 2, even an extra line which has nothing in it, it will not run. It will give you an error. It will not run 100%. And lastly, the first line should always be this. Should always be this. I hope you understand what that means. Now we can create our GitHub repository, our directory, and start. So let us now move to now creating the GitHub repository, the directory, and now do the files and the tasks. So let me go to my repository on this side. I will create new to create a new repository. I will copy paste the name. It is copy paste the name. It is supposed to be called ALX low level programming. Yeah. Make sure you have a description for that. Don't tick anything else. Because now for the README we'll create it within our sandbox. Yes, we'll create it within our sandbox. So create. After creating it, the next thing we need to do is we need to clone it into our sandbox. So let's get a sandbox and then clone it from there. So open your sandbox, check where you currently are with pwd, list all the files. Yes, so we need to cd into root and then list all the files. So far we have ALX system and empty directory and the other one. So now we need to do the cloning of our repository from GitHub to come into our sandbox. So we do git clone. I hope you got that one right. Git clone. This is what we will be copy pasting. So you need to copy paste your link, which is this one. I will copy paste it into my document over here. We are git cloning. This is where we are git cloning. So it is that. So what I prefer is to actually put the token in a different document and then bring it all into my sandbox. So here, this is my token. This is my token. So I'll copy paste it, and it needs to come between the / and GitHub. So I'll paste it there, and it also needs to have an @ So once I have done that, I copy my entire code, come and place it here, and run it. Yes. So please make sure you note this. It should tell you that you're cloning into ALX, and we have appeared to have cloned an empty repository. It is empty because we don't have anything in it, even an README file. It is not there completely. So now when we list our files, we now have our repository, which is ALX low-level programming. I hope you got that one right. So the next thing we need to do is cd into ALX low-level programming, and to do that I will do ALX low-level programming and cd into it. And before we do that, we need to have a readme. In our repository, so we can go back one step and now have a readme in our directory. So yes, actually we're on the right track. Sorry, cd, we need to move into our directory. Yes, so we can create a readme. So I will vi readme.md and I will just type the so what I will do here, I will just type in the name of the GitHub repository, but feel free to have it be whatever you want. It should be descriptive, but for me, I'll just put the name of the GitHub repository inside for ease, and then escape and quit it, right and quit it to save it. And now the next thing I need to do, I am in my ALX low-level programming, and you can see where you are using PWD. So the next thing I want to do is create now my directory called 0 hello world. 0 hello world. I hope you got that one. I want to do 0 hello world. Yes. So the next thing that I need to do now is create the directory. So we do that by mkdir. So that is short form for make directory, and copy the name of your directory, which is 0 hello world. 0 hello world, and paste it there. And now if we do ls, we should have two files. One is the readme, which we have created initially, and the second one is 0 hello world. So now we need to move into 0 hello world, and here we also need to create a readme. So we do vi readme.md. I hope you got that one right, and the only thing I'll put is the name of the directory. As I've mentioned earlier, you can put anything as long as it's descriptive for you to understand what is happening. So let me do that. Escape and right quit. And if we are to ls, we should see the readme file. I hope you got that one right. Please make sure you follow these steps because you need the readme in your repository and in your directory. If not, it will not run and it will give you errors, and you might not be able to know what is happening. And your readme should not be empty. I hope you get that one. So now you can clear and you can start working on the tasks. I will put this on a different view. I'll put it there so that you're able to see. So the very first task that they want us to do is they want us to write a script that runs GCC. So the first thing that they want us to write is a script that runs a C file through the preprocessor, and then it saves the result into another file. It will save the result into another file. So what is happening here, if we go back to our steps, is they just want us to run it through this first step, this pre-processing step, and then it will give us an output. So they don't want us to do the entire process, they just want us to do this pre-processing step. I hope you got that one right. They just want us to do the pre-processing step. So what I have done is I usually research and put it down first. So let's look at our solution that I had actually done before, and then we go through it before we actually do anything else. And one thing I want us to do is please make sure you are able to create your README, because now we have cloned, create the README, as I have mentioned. Make sure you follow Betty Linter style. And if you are not able to understand what GCC is doing, just type GCC dash dash help, and it will give you all the GCC options. If you want us to go through that as well, please write it in the description and we will definitely do it. We are here to help you learn, so don't shy away. So I had actually put my answer here. So remember, they always mention that this needs to be our very first line in every single file, and this is a shebang line, and all it does is it specifies to the interpreter that it should run the script. In this case, it will run it in bash. So here what they want us to do is they want us to run a file through the preprocessor. So we need to call GCC and we need to say -e, and the -e, what it says is it tells it to stop after the pre-processing stage. So it won't run all the way until linking stage. -e just tells the interpreter and tells the compiler, sorry, the GCC compiler, that when you get to the pre-processing stage, please stop here, and whatever results you have here, put them in a C file, and the C file is this name. I hope you got that one. I hope you got that one right. So it should contain the result of pre-processing, and what they should be stored in a file called C file. And the last part, which I have highlighted, the -OC, this specifies that the output file for the pre-processed code should be output into a file, and the C is the file name. So I hope you got that one right. I hope you got that one right. So if I am to go through it again, what it does is this script takes a C file, which is our source code, processes it, and saves the preprocessed output to a file called C file. Called C. So this C file, this is a variable, as I have mentioned, and all it does is it tells the compiler the path to the C file to preprocess. So let's put our solution in and see if it runs. I hope you got that one right. I hope you got that one right. So let us put it in. So we need to VI, and our document name is zero preprocessor. Zero preprocessor, we paste it there. And now we are able to edit it, and we have said it is bin slash slash. Sorry, I've missed one forward slash between the two. Sorry. Yes. And then now we have GCC dash capital E, which is the option for telling it to stop after it gets to the pre-processing stage. And then now the next thing is the variable for telling it to the variable which contains now the path to the C file to preprocess. I hope you got that one right. It contains the C file to preprocess. And now the next thing we need to do is -O. So that will be small, and C. I hope you got that one. And then now we need to escape and save this. So it will not be there. C. So we need to press escape for us to exit from writing and save it. So that now that we've done that, we need now to create the main C file, which will contain this code that is here. So let's do that. Let's just do vi main.c, and we should put, it should contain this content here that they have provided for us. That one. So let's quickly do that. Yes, it is. And now the next thing we need to do is quit it and save it. Nice. And after that, now we need to be able to run this command, this one over here, export C file into main.c. And after that, now we need to try and see what is happening over here. So now the next thing we need to do is create the main.c file, this one. So we copy that name and do vi, the name main.c. And now we want to insert this code that they've given us. This is the code that contains the main, it contains the main function. So we type it there. And I want us to see something. Let's just type it as it is and then we save it and we try run bt. I want us to see something main.c. So it will run and it will tell us that we should not have any space at the start of a line, and our error is on line 10. So now let's go back into our document and see what that is saying. So if you're to count, you'll see that line 10 is this one that has the return in parentheses 0. So we need to remove the space before that. And to do that, so now when we remove that, we need to save it. And when we save it, it should now run. When we now run bt, it will now be okay. It will not give us any errors. Nice. So the next thing we need to do is we need now to change the mode for our file that we have created, which is the zero preprocessor. We need to change its mode so that it can run. So we do that. And that is that. So the next thing that we need to do now is we need to export the main.c into a file, into a path called C file. So let's put it here. And the next thing that we now need to do is run this to run the file that we just created. It runs, and for us to see if it has created, we can do ls. And as you can see, we have a file called .c. So to see the content of that file .c, we come here and it gives us the few lines of the code that we have. So now we can add this to our GitHub and commit it. I'll just commit it with the file name. And finally push it. And now I want us to run the code. Now it is running. Now we can run our code and see if it's okay. Everything should check. If not, we can just review it and see what went wrong. But please make sure you follow each and every single step that they have outlined there. It is important to follow the steps, otherwise you'll have errors in between. As it is running, I can clear this. Yes, so as you can see, all the tests have run and they've run successfully. So now we can move to the next one, which is the compiler step. And here we still have the file, the main.c, but here they want us to write a script that compiles a file but does not link. So what essentially they want us to do is it has compiled, but it will not link it. So here we create the file and it is called one compiler. So here we create the file and it is called one compiler. So let's pick this and do vi So essentially what they want is, if we can go back here, they want the process to continue, but it will not link. So the step before linking is it will create an object file. It will create an object file. So let's look at the code and what it does before we actually type it out. So that this is the code for it. So we have GCC, which is the compiler, and the -c option. What it tells the compiler to do is it should stop after the compilation stage and generate an object file. And the C file, the $C file variable that will contain the path to the C file to compile. So let's do that right now in our what is it called, in our sandbox, and we escape and we save it. Once we do that, the next thing we need to do now is change its mode. So, sorry, that is not the correct thing to do. So we need to change the mode of one compiler. Let me copy the name. This is why I insist that you need to always have the name chmod u plus x and the name. Yes, and the next thing that we need to do after that is run this. And after that, we can list our files and we should be able to see the .c file and main.o. Here it is, main.o, which it wasn't there before. So now we know we can proceed and move to the next step. So the next step now will be to add it and to commit it. I'll use the name of the file as the commit message and finally push it. Now we can. Now it has run successfully. Now we need to move to the next step, and the next one is the assembly step. And here we're supposed to write a script that generates the assembly code of a C code and saves it in an output. It will save it in an output. So here, let us look at our solution. So our solution basically. So let us look at what the code does for this, and always remember to read the instruction. So the C file name will be saved in a variable called this is the variable name, and the output should be named as the C file, but with the extension of .s instead of .c. We will see how we will do that. So let's look at the solution for this. So the solution for this one, this is it. So it's the one for the assembler. So here what to do, the bin bash, that one is the standard one that should be there. And now we use GCC, and here we have the -s option, which tells the compiler that it should stop after the compilation stage and it should generate an assembly code. I hope you got that one. It should generate an assembly code. And here now the assembly code, if we go back here, it is this assembly code, and assembly code will have a .s. It will have an input for .s. I hope you got that right, but I can repeat it. So what this will do is it will run the GCC compiler with the -s option, and it will tell you to stop after the compilation stage and generate assembly code. I hope you got that right. So the resulting assembly code will have the same name as the input file, but here it will have a .s extension. So that will be that, and the resulting assembly code will be main.s. So we can copy this and see what will happen. We can put it here. So you can clear this and copy the name of the file. Copy the name of the file, which is toassembler. and copy the solution that you have. Pick it, copy it. But I'll suggest you type it out because it is important for me just to save time and to speed up the process. I will type it here. No, I didn't copy it. Okay, I've copied it twice. So always make sure that you have only 2 lines of code, otherwise it will not run. Okay, C file. Nice. Need to escape. So the next step now that you should do is save it. Okay. Save it, and when you do ls, it's there. You also need to change its mode to, and now after that, the next thing that we need to do is run this for it to run. You said no input in the file, so let's look at that. Compilation has been terminated. Now we can cut to assembler and see what is inside. So we have that, so maybe we need to run this first. So now it has run successfully. So make sure you just follow the steps, otherwise, as I mentioned, it will not give you the correct output. So now the next thing that we need to do is when you do ls, we should see main.s, and it is there, main.s. And now after that, we just need to git add and git commit. I hope you're following. And here, as I've said, I'll just give a commit message for the file name. And finally, git push, so that it can go to git and we can run our checker. So now let's check our code and see if everything is okay. As it is running, I will clear. It has been successful. So the next question is, we should write a script that compiles a C file and creates an executable named C is fun. I hope you get that right. So here we need to create a script that will compile a C file, and at the end it should compile. It should create, an executable file called C file, and the C file name will be saved in a variable called $C file. So now let's go to the code that I had earlier researched and I had written my solution. So here it is. So an explanation of this, now we know what GCC does. It tells it, it runs the GCC compiler, and here with the $C file variable, it will contain the path to the C file to compile. And the -o, it is an option that will tell the GCC to write the output to a file. And the name of the file is C is fun. So it is just that straightforward. So I hope you got it. So now we copy our solution and we type it in the name of our file, which is 3 name. So vi3 name. And then we insert our solution there. Make sure it is 2 lines. And then we escape and we save it. The next thing we need to do is we need to create the path. Always follow the steps. Create the path. And then after that, we already have the c.main file, so that is okay. And then now we need to run the file itself. But before we do that, we always need to change it, the file to be executable 3 name. And then now we can run this command that is here. There, nice one. And then now when we ls, we should see C is fun. And you should see main.o. It is main.o. So make sure you follow the steps and you see all this that is happening. So the next thing that needs to happen is we need to add it to Git, and then commit it, and we have a commit message. And here we will just type the name of the file and eventually push it to GitHub so that we are able to check our checker. So now let's check our checker and see what results it will give us. As it does that, let me clear the output, and that has been successful. So we move to the next one, and here what they're telling us is we should write a program that will print exactly this. So what you need to note here is we have this that I have highlighted here, the quotation mark at the beginning, and followed by this. So anything that is here in red, that is exactly what should be printed. And after this, it should be followed by a new line. And here we've been told that we need to use puts and you're not allowed to use printf. I hope you got that one. You're not allowed to use printf, only puts. So here we do vi, the name of the file, which is for-puts.c. There it is. So now we can go and check our solution and explain it before we continue. So here, this is our code. So remember, we always include the header file. This is the commenting style that we're using, recommended by Betty. This is the main function, and this is the body of the main function. And this is exactly what they want us to do. So here, let us explain what is happening. The hash include, which is this one over here, what it does is it will include the standard input and output libraries. And here they will provide the function, which is the puts function, which is used in the program. It also has other functions, but here we want to use the puts function. And then the next thing is we put the comments. And as we mentioned, comments help us understand what our code is doing, and it will also help another person understand what the code is also doing. So make sure you use Betty and you use Betty style like this. If you want further explanation on how to use Betty, let us know in the description and we'll definitely do that. The next thing that we now have is the int main void function, and this is the entry to the program. Each and every C program must have a main function, and at whatever point the main function is, that is where the program will start. It doesn't care what is above it, but that is where it will start. And what it does is it will return an integer value to indicate whether the program has been successfully completed or not. And in this case, it will always return 0, which is this last one. So here it will always return 0 to indicate it is successful. And if it returns anything else, it is not successful. So here we are using the puts function. And what you need to have is this, what is here in red. That whole thing that is there. And we need to see something here. You see this backslash? It is an escape character for us to be able to escape this double quote here, which is supposed to be printed out. If you don't include this backslash, which is an escape character for what is coming next, it will not print. It will just print programming is like building a multilingual puzzle. I hope you got that one right. So now let's take this and copy it in our solution, in our sandbox, paste it there, and save it. And then now the next thing that we need to do is let us change the mode. U plus X and the name of the file, which is for puts.c. And now we can git add. Or before we do that, we should run this that they have given us to do here. Let's paste it there. And it is giving us exactly what they want us to do here. This initial double quote is here. So please make sure you do exactly as I have said. I hope that is correct because that is the output they want. So now we can git add git commit, and I commit it to the name of the file, which is for puts.c, and push it. And now we can run our checker. We can now run our checker and see what is happening. I hope it has been successful. If not, we will go through whatever is happening and correct the code, but for us it has been successful. So now we clear our sandbox so that we're able to move to the next task and close the checker. So the next one is they're telling us to print exactly this. This is what they want us to print, exactly this. And here we have the comma at the end followed by a new line. But here we've been given the permission to use printf. We've been given the permission to use printf, but we can't use puts. And at the end of it, the program should return 0. And the program should compile without any warning using this option wall gcc. So let's create the file 5 print. Create the name of the file vi, and now let's look at the solution that I had earlier researched on. So this is it. This is the solution that we have over here, and what it does is we import the library, we have the comments as earlier described, the main function, and we have this. So here note that with puts we did have this at the end, which will help us print a new line after we finish printing that. But puts automatically it will do that, and we will later on see the difference between these two. I hope you got that one. So here we just put the literal, whatever it is that we want to type. I hope you got that one. So now let's copy our solution and see what is happening. If you have any questions, please leave it in the comments down below, and we'll definitely try as much as we can to look at it and provide the best way forward and the best solution. So that is our solution. Then we escape and we save it. And the next thing that we need to do is we need to change its mode. Always remember to change its mode, otherwise it will give you a lot of stress. So 5 print and all that is what you're working with. And now after that, we need to run this, which is the option they've given us. And it's been successful, and we can run this to see what is happening. This a.out, you can have it there. So there, we have the output, and it is exactly as it is, even with the comma at the end. So now at least we know we are good to go. Now we can add it, and then we can commit it, and we save it with the name of the file, which is printf .c, and finally git push. And now we can go and check our code. We can now go and check our code. As it is checking, we can clear this on this side for us to move to the next step. So we can close this. The next one is the size is not grandeur and territory does not make a nation. So here you're supposed to write a program that will print the various types of that you have on your computer, and it is compiled and run on. So you should produce the exact same output as in the example. And what they mean by that is this example, this. So this is exactly what they want us to actually print out, and this is some of it is what we will use in the code, the source code. Some of it we will kind of refer to it. So here warnings are allowed for this one, which is a good thing, and your program should return 0. And you might have to install this specific package on Linux to test using this. GCC option. So let's create the file and look at the solution I had earlier researched on. So here we do have our solution, and what is happening here is we definitely have our header file which contains many functions, but the specific one we're using here is printf. And we have our comments to tell us what is happening in the code, and it is using Betty style. We have the main function, which is the entry to the program, and now we have the function to help us print the text that they want us to print, which is this. So here I want us to notice something. Whatever is before the semicolon, this, in every single answer, whatever is before the semicolon, that is literal, and you just print it as it is. But for us to be able to get the size of a character, depending on the particular desktop or PC that you're using, this is how we do it. We use this, which is a format specifier for a decimal, and the next thing we have is bytes, which is that, and that will be a literal. So here we have size of. I hope you're following. We have size of. So what is happening here with size of is it will help print the size of the specific data type that we are looking at. So for the first one, it is character. So it will help us find the size of a character data type on our PC. Then the next one it will look at the data size of an integer, the next one of a long integer, of a long integer, and then of a float. So that is why we have here the size of, and the parameter that we pass into it is the specific data type that we want to look at. So that is why you see here the size of character, the size of int, the size of long int, the size of long int, and the size of float. I hope you can see that, and I hope you understand that. And as I've mentioned, %d is the format specifier used to print an integer values. And in this case, it is the size of the specific data type that we want to look at. And at the end of each statement, which is what you have here, as you can see, each statement, it has for \n, and what is happening here is it will add a new line character to the end of that string after it is printed. So we'll be able to have all these sentences in different lines. If we don't have that, it will print everything in one line. So I hope you understood that. So now let us copy our solution and put it in the sandbox. There it is. And then now we can save. And then now the next thing we need to do is change its mode. 6 size.c. 6 size.c. And then now we can run this option. If your device is a 32-bit processor, mine I believe it's a 64, so I will run this. And it's run successfully. And now I will run the 64 size option here. And it will print exactly what is happening here. So on my device, a character occupies 1 byte, an integer occupies 4 bytes, a long int will occupy 8 bytes, a long int will occupy 8 bytes as well, and a float will occupy 4 bytes. So I hope you got that one, right? So now we can add it, we can commit it, and I will save it with the name of the file, which is .size. And then after that, I will push it. Now that that has been successful, let us go and run our checker. If there's any error, we will correct it. If not, we will do the advanced tasks. And here I would like to let you know that you can subscribe so that you don't miss a bit. Anytime we post, it will notify you. And for you to be notified, please click on the notification button. We will be posting different videos. One, will be posting the content review just to make sure you understand the content and you understand the concepts. And the second thing we will be doing is we will be taking you through and explaining the steps for the different tasks. So now that we have done that, we can close this and we can now move to the advanced solution, the advanced tasks, sorry. If you got this far, also let us know if all your solutions were successful for the mandatory ones. And if they were, please give this video a thumbs up. It will help us help you better and serve you better. And it will also help others as well who need to see this content and for them to be able to learn and grow as we build a better Africa and we become Africa's tech gurus. So now let's move to the advanced tasks. So for the seventh task, we're supposed to write a script that generates the assembly code or Intel syntax of C code and save it in an output file. And here the file name should be saved with the variable $C file, and the output should be named the same as the C file, but here it will have the extension .s and not .c. So here we will look at how to do that. So let us look at the solution that we have. So here we always have this first statement, and I will repeat it. It will tell the GCC compiler that it will run in the bash shell. I hope you got that. Sorry, it will specify that the script, not the GCC, the script should be run in bash shell. So the next thing is we have the GCC command, which is this at the beginning, and it will use to compile and assemble C source files into an executable file. But here we have the .s option, which is the next one, and it will tell the compiler to stop after generating the assembly code. If we go back here, we have the steps pre-processing and then compilation and then assembly. So the -s tells it to stop after it has generated the assembly code. I hope you got that one, rather than generating the object code or an executable file. I hope you got that one right. So the next thing that we have is mass-m equals to Intel. -m equals to Intel, and this option will tell that the assembly code should be in the Intel syntax and not the default one, which is provided, which is AT and T syntax. I hope you got that one. So it will do that. It will specify that we need it to be the Intel syntax, which is what they had mentioned here in our code. Here, they have specifically said that it should be in Intel syntax. And the last option for GCC is the $C file variable, and it is used to specify that the name of the source file to be compiled, and it will set to the actual file name before running the script. So at the end of the day, the script will be used to generate Intel syntax assembly code from our C source file, and it will use the GCC compiler. I hope you understood that. So let us copy this and put it in our sandbox. We need to create the file first, which is 100-Intel. And now we edit it, and when we edit, we put in our solution, and then we save it. And then the next thing that we should do is we need to export this C file and then run it. We already have our main.c file, and now the next thing we want to do is we run the file that we've created, but we need to change it first. 100 Intel, and then the next thing after that is we run the file itself, and it has been successful. So now let's look at the main.s file, because they mentioned is the output should be a main.s. So now we know that it has run from preprocessor to compilation and stopped at assembly and produced a file with that .s file. And in this case, our file was main.c. So here our file will have main.s. So let us look at cat main.s. And there we have that. It's a lot to take in, but that is the output that it should give us, which is the same as what is here as well. So now we can safely say that our solution is successful, and you can add and commit it. And here we will commit it to the name of the file, and eventually we push it to GitHub so that we are able to run our checker. As the checker is running, let me clear this sandbox, and it has been successful. So now we can comfortably move to the next step. Feel free to pause at any step and take it in and rewind and repeat until you're able to understand the concept. So here we have 8 Unix. The 8th task, which is advanced, is Unix is basically a simple operating system, but you have to be a genius to understand the simplicity. So at the end of the day, we're supposed to write a C program that prints exactly this. Whatever is in red, that is exactly what they want us to print, and it should be followed by a new line. So here, please remember the concept of using escape characters, and one of the useful ones here that we'll be using is the backslash to escape special characters that we do have here. So at the end of the day, it should also be followed by a new line to the standard error. And we are not allowed to use any function listed in the name section of the month 3, and that is printf outputs, and our program should return 1, and the program should compile without any warnings when we use the GCC option. So let us look at the code that I had found to be a solution for this. So this is it. We do have the 2 standard libraries that we have with us, which is the standard IO and this. And at the end of the day, so here we have this other library, std.h, which is another header file. And then you also have the comments using Betty style. Don't forget Betty style. And we have the main function there, and it starts with main. And at the end of it, we now have the body of the block of code of the main function. And here we're supposed to print this exactly as it is. We should print this that I'm pointing over there. So now when we look at the body, this here we have a write, which is the system call, and it will help us print to the a message to standard error, and it will take in 2 arguments, and the message will be enclosed in double quotes when we use write. So anything that is in double quotes is exactly what will be printed. And remember that we've used this backslash to escape this double quote, which is part and parcel of the output that will be there. I hope you remember that one. And the message will read this as it is. This is what it should read. And that piece of art is useful. Dash, double quotes, dash Dora Corper, comma 2015 dash 10 dash 19. So that is what it should do. And what will happen is the message will read this, which is a quote from a fictional character, which I have no idea what it is. But at the end of it, this is an error, and the program should return 1. The program should return 1, and it will indicate that it is an error. And where is this error coming from, if you might ask? It is because the message has been printed to the standard error. As you see, they told us to print it to standard error, which is an error by itself, because normally it should go to the standard output. I hope you got that one. It should normally go to standard output, and the convention is to always return a non-zero value in case there is an error. So here the program will return 1 to tell us that there is an error, and the error is because it has been printed to the standard error instead of standard output. So I hope you got that one right. So now we can copy this and put it in our solution, which is 101, sorry, quote.c, and we edit it and we paste our solution there and save it. And now the next thing that we need to do is our program should compile without any warnings using this option. So here we use this option to run GCC. I hope it is successful. It has been successful because we have moved to the next step, and now we can run the executable file that was provided. So there it is, and we forgot to change the mode of the file, which is 101.c. That has been successful, and now we can successfully add and commit, and we do 101 dash quotes.c. That is the commit message, and now we can push. Hopefully everything runs perfectly when we run our final checker. If you have been with us till this point, we really appreciate you for taking time to allow us to take you through these tasks and to teach you so that we become better African tech gurus and we bring solutions home and we create homemade solutions. So now that it has been successful, we can now completely say that we are done with today's tasks, and it has been an honor. And until next time, have fun, continue coding, share this with a friend who's in need, learning tech, who's doing this so that we are able to grow together. And until next time, bye.